Assalamu alaikum and good afternoon, everyone. In fact, it is good morning for some of our speakers, including Dr. Narissa Bax. Myself, Muhammad Ashraf from Center for Environment and Marine Studies, CEMS, and I will be moderating this session in this technical forum on blue economy in the Arabian Gulf and the Red Sea. First of all, on behalf of CEMS, I would like to welcome all of you to this session. This fourth session highlights on blue economy assessment. We have two talks in this session, and it will be followed by a concluding session for final discussion and closing remarks. Each talk will be 30 minutes, followed by a 10 to 15 minutes for question and answers. You can either ask the question by writing your queries in the question answer chat box or by raising the hand option. The first speaker in this session is Dr. Narissa Bax, a Marine and Coastal Program Coordinator at South Atlantic Environment Research Institute. Dr. Narissa Bax is going to talk on a topic named Potential Blue Economic Concepts for Saudi Arabia based on case studies in New Zealand, Myanmar, and Falkland Islands. Dr. Narissa Bax is a Bindi ecologist working with the Antarctic Seabed Carbon Capture Change Project, which aims to understand the function of polar and subpolar seabeds in the carbon cycle, Antarctic Blue Carbon, and the Center for Marine Socioecology Future Season Initiative, leading the Coastal Blue Economy Challenge to inform the United Nations International Decade for Ocean Sciences for Sustainable Development. In her role as the Marine and Coastal Program Coordinator in South Atlantic Environment Research Institute, she focuses on research and development to sustainably conserve a network of marine management areas aligned to international criteria for marine protected area designation. With this brief introduction, I would like to welcome Dr. Narissa Bax to this technical forum and request her to present her talk. The floor is yours now, Dr. Narissa Bax.
Okay, thank you so much. It's wonderful to be here and I appreciate the opportunity. I'm going to start sharing my screen now so that I can continue with the presentation.
Please.
Okay, can you see that all right?
Yes, we can see now, yes.
Okay, wonderful. So I'd like to start by talking a bit about how I was introduced to your workshop. And so Moritz kindly invited me in connection with a paper that I led on ocean resource use, building the coastal blue economy. And this is what will guide a lot of the case study approach that I'll use in this talk. And this paper is part of a broader collaboration called Future Seas, so through the Centre for Marine Socioecology in Hobart. And it's a large working group of over 100 researchers across disciplines, which included really diverse fields, so psychologists, ecologists, oceanographers, economists, social scientists, governance, law, policy, and one of the really important components of this project was that we had a large cohort of Indigenous scholars that contribute to discussions and resulting publications as well. And so the project was framed quite broadly, and there's been, I think, a lot of emphasis on that this year to incorporate the Sustainable Development Goals and the UN International Decade of Ocean Science for Sustainable Development, which started this year and runs until 2030. And so the Future Seas method was aimed at developing evidence-based scenarios for the future by 2030 and for 12 key challenges which are listed on the left. And then from there, we generated a tangible plan for possible actions at local, regional and global scales to undertake and achieve the vision for 2030, which was most in line with an equitable and sustainable future. Another important aspect of this within the Sustainable Development Goals was to, kind of target in on what was most important for the blue economy. And so specifically SDG 14, which is life below water, and it's also considered the most synergistic sustainable development goal and most applicable to blue economy planning because in theory, it put forward multiple targets from which nations can measure and communicate effectively as well. And so the targets range from reducing marine pollution to ocean acidification, the implementation of marine protected areas, and sustainable use of marine resources in small island developing states. So with the specific focus to conserve and sustainably use the ocean, seas, and marine resources for sustainable development. And the international endorsement from the UN acknowledges that oceans support life on our planet, and there are significant opportunities for many member nations of the UN to grow their economies through, for example, coastal restoration, climate adaptation, and transitions to renewable energy generation and ecosystem-based management of fisheries. And so the paper that I'm using as an example here is one that I sort of worked on in as an aside whilst we were doing the Future Seas project, because there was so much emphasis in the lead up to the Ocean Decade. And so this puts forward from an Australian perspective how much we are actually measuring success in terms of the Sustainable Development Goals. So you can read that in Raise et al., and this is the infographic on that paper. And it's sort of what we found once we started delving into the targets is that, you've got a very siloed approach of how reporting and activities are undertaken by different groups. And Australia, possibly like Saudi Arabia, currently possesses, quite broad infrastructure, technology, and capability to monitor the SDGs against SDG 14 with high quality data sets, and the data is available from several monitoring agencies. So the capacity is there to have a more holistic approach and address multiple goals collectively rather than individually, and use this in domestic policy and planning and reporting. However, there's a failure to appreciate this at the scale needed currently. And so this can lead to conflicts, for example, between stakeholder groups. There's an inefficiency and a waste of resources, while this recognition of synergistic interactions between the indicators and associated targets improves the assessment process with significantly lower cost and multiple benefits that are not necessarily measurable or measured as well in terms of the benefits to nature and benefits to society. And so in coming up with the sustainable futures across these challenges, the process began by visualizing a business as usual, which you can see, and depicted on the left, and on the right, the more sustainable future. And this image is taken from Trebelko et al. 2021. So that's the challenge on ocean warming, and it illustrates some of the sustainable technologies that are applied in ocean environments and that could become more commonplace globally. However, despite the need to focus on technology and restoration, we're also still incredibly lucky to have large areas of remote biodiversity and functioning biodiverse ecosystems, such as the coral reefs in the Red Sea, the kelp forests here in the Falkland Islands, and the unique abundant life on the seafloor in places like Antarctica, which Dave Barnes presented on earlier as well. And so what I was reading about in the context of the Red Sea is that these coral ecosystems are shown to potentially withstand ocean warming, not just in shallow ecosystems, but also possibly in deeper waters. And these ecosystems provide really invaluable insights into how marine organisms might cope and respond to extreme environmental conditions, for example, and the lessons that they might provide in a rapidly changing world. So what I wanted to do here was sort of amend to that graphic and touch on a bit of what Dave pointed out in his talk on blue carbon at the poles and our planet, which is facing climate change, but also species loss. So the issues that are interlinked, and climate mitigation by nature is actually far more efficient in terms of climate adaptation. And so our efforts in this area are maximized in systems that are considered intact, so undamaged, unfished areas, and that have been in place long term. So ideally in marine protected areas where you have no take protections, and also the water mud interfaces such as the sea floor. So life on the seabed can be very efficient at sequestration because it lives at the site of potential. And the millions of tons of carbon that marine life, so blue carbon, can bury only works if properly protected, and recovery takes a long time. So I think in Dave's work, he pointed out that they've shown recolonization on the seafloor to take about 40 years from scratch. So much of the sustainable future is reliant on our marine biodiversity functioning effectively to store and ultimately sequester carbon long-term on the seafloor. And so on this graphic, you have our project on Antarctic blue carbon, but also on the left, so one of the case studies we were talking about for the Future Seas was the Sustainable Seas project in New Zealand. And so that provides more of a contribution to nature-based solutions to climate change and biodiversity protections, such as marine protected areas, but in combination with biodiversity intervention projects such as seaweed harvesting, for example. And also more broadly, involvement with these really multidisciplinary, high-level future seas type of projects and the work on Antarctic blue carbon taught me a lot about what multidisciplinarity can mean and how to navigate unique approaches to marine conservation. And blue carbon as an aspect of the blue economy provides this kind of holistic frame, like a ecological currency and value system that is a good example of something that I think maybe all of us have seen across our research lifetimes, is that we don't solely witness ecological change, but we also see changes in how we communicate, the terminology we use, the people and expertise that we engage in, and all of those sorts of things towards conservation aims. And so how these protective mechanisms manifest is quite dependent not only on the ecology, but also on the legal considerations. So this image here is from Navaglio et al. 2021, which is the Offshore Blue Economy Challenge for the Future Seas. And we focused on the exclusive economic zone, which is seen as a key gap in research focus and also a key area of potential for change, because so long as the governance and resourcing is sufficient, the national capacity for sustainability is considered heightened. It's also differentiated from the coastal zone. So when we were dividing up the expertise, it gave a lot of scope to explore more of the human side of the challenge for the coastal blue economy, because the coasts tend to be quite overcrowded, often conflicted spaces with multiple resource needs to consider and multiple people. So cities are considered at the forefront in most urban centres, so about 70% are located along our coasts and waterfronts around the world. And 97% of the world's fishers live in developing countries, with fishing the major source of food and income, for example. So threats to the ocean therefore have the potential to engender widespread suffering, displacement, unrest, and there's many moral considerations as well. And so what we started to see as well is that the idea of sovereignty and legality underpin much of the blue economy and how you can plan and move forward. And also thinking in terms of beyond the exclusive economic zones, so especially for nations with more wealth and more capacity, there is a huge need and huge benefit to focusing on conservation in areas beyond national jurisdiction, because this area accounts for nearly 2/3 of the world's ocean, where no single state has authority. So this area reaches depths of over 10,000 metres and represents 95% of the Earth's total habitat by volume. So considering that nature sequesters carbon more efficiently and cost effectively than technology, for example, especially on locations like marine shelf habitats. Work by a researcher called Marcus Diesling recently put forward there's estimates of up to 60% of organic carbon accumulates there, for example. And so the current national and political barriers are possibly our most significant barriers to sustainable blue economy goals. But if we can resolve more global conflicts, a more meaningful approach to conservation would be to target conservation of our high biodiversity habitats to retain their essential integral ecosystem functions into the future. So moving forward to the paper on the coastal blue economy, in choosing our case studies for this paper, we were quite purposefully dichotomous. I think a project like this lends to having to be. So the idea of business as usual versus a sustainable future is equally quite dichotomous. And there is much in between to consider based on each and every geographic location. And so we tried to break it down into a matrix in order to reach our sustainable future by envisaging actions towards conflict resolution. And so this was chosen as the driver because it's identified as a key driver that society can influence and that will impact the future of the coastal blue economy and thus support society in moving towards a more desirable future. So I'll talk through these actions in the coming slides, but I must add that there's some pretext and theory for this process, whether it's to apply it elsewhere. So I've not had the opportunity to apply it in the Falkland Islands, for example. It does rely upon broad-scale multidisciplinary groups getting together and teasing apart these issues. And it would be up to those contributing to the workshop to apply it in a more fine-scale context to Saudi Arabia as well. So some commonality that I was thinking about recently, possibly in terms of maybe my own bias of research focus and priority, is somewhere like Saudi Arabia, Myanmar, New Zealand, Falkland Islands. These areas all represent isolated, high and unique biodiversity with high incidence of endemism, but with possibly quite insular, complex and not easily comparable governance models. And so I think it's important to, throughout this process of what a lot of projects are using, it's future casting, to also point out and recognise our own bias and knowledge basis. For example, many case studies were put forward for this paper, and ultimately for the ones chosen, our working groups had bias and unique insight to them. So for example, I'm from New Zealand. I worked and lived in Myanmar in 2016. And I have long recognised that these experiences shape the way I perceive and approach the world. So this is called a worldview, something we all have, defined as a particular philosophy of life or a conception of the world. And in this paper, importantly, we had Maori expertise from Dr. Kimberly Maxwell, working in Maori fisheries and aquaculture and marine ecosystem-based co-management. And from the Myanmar perspective, we had Zhao Lun, who's working with locally managed marine protected areas, for example. So there's more differences to highlight between these two case studies, but the most obvious is that one is more affluent than the other. And so it sort of provides the dichotomy of a developing versus developed nation comparison. And there's this considerable difference in population size, governance, but the commonality would be high biodiversity. And even there's very different ecosystem types and biological connections and resources. Further, the Future Seas scoping process started at the end of 2018. So our choice of case study also highlights disparities that were maybe unexpected and not planned for, so such as COVID, and also the political turmoil in Myanmar this year, and political conditions in Myanmar currently highlight really desperate need for adequate international outside support to secure the foundation of the following synergistic blue economy actions that I will discuss next. So Action 1 is considered the first step, that change must be motivated and facilitated. So recently at the global level, we've just seen COP26 commitments by 151 nations to their nationally determined contributions to decarbonisation strategies to prevent warming to 1.5 degrees Celsius by 2030. However, as these stand, the UN estimates that globally we're still on track to reach 2.5 degrees Celsius. So there is much to be done to actually bring this work onto the ground. And so large investments are required to diversify economies, supporting communities to transition into alternative livelihoods, and providing tools and incentives to shift sustainable practices. Such response pathways could include avenues like financial schemes. So we put forward options like universal basic income or conditional or unconditional cash transfers. So kind of something that's similarly applied in disaster relief programs. And this ties in especially well to mangrove conservation, for example. So I've applied in Myanmar. Mangroves contribute about $65 billion in terms of their ecosystem services to flood defense and the coastal filtration of the ocean globally. So this type of support would improve the resilience and social safety of communities and instigate an economic transition away from counterproductive activities, so such as illegal extraction of resources, for example, which eases the pressure on ecosystems. There's also capacity for more inventive, innovative approaches that might combine these types of initiatives with others, so such as leasing of key conservation habitat and building around the carbon market and offset opportunities with tools and financing. So blue carbon ecosystems store carbon like trees and have a source of emissions if they are destroyed or degraded. So this type of work was a huge focus at COP26 with 71 countries with various decarbonisation commitments, and many of them explicitly mention blue carbon. Vera is the certification body that I've put up there as an example, and they have created a carbon credit for mangrove, seagrass and salt marsh blue carbon. And there's also kind of a model first project that is generating blue carbon credits you can buy. And this is on the north coast of Colombia with 11,000 hectares of mangroves, providing a test case for similar community managed blue carbon projects, where blue carbon credits provide financial support for biodiversity, sustainable fishing and livelihoods and other climate change adaptation initiatives. And although this type of financing and capacity is in its infancy, with sufficient motivation and facilitation, the money and value are not always linked. So looking towards Australian markets, for example, the carbon price is currently 28 Australian dollars a tonne. So I worked that out into, that's 75 Saudi Rial. And it was at 14 Australian dollars a tonne initially. So that's 37 Saudi Rial. And so this is because something like blue carbon credits can be sold to other buyers. For example, traditional land owners who practice traditional burning methods in Australia sell their credits to Qantas, which is an airline company, for a higher price than governments would buy, for example, because Qantas, like many organisations, will possibly be looking for co-benefits of supporting a more meaningful offset option, for example. And there are examples of industries looking to be carbon neutral. So, for example, from our polar work, there's the subantarctic Kerguelen fisheries company called Austral, which aim to be carbon neutral and sustainable fishing. And so for their carbon neutrality at the moment, they offset by investing in terrestrial ecosystems. But in terms of efficiency and capacity and benefit, there's a lot more to be gained if we start making this possible in our marine ecosystems. And so this is a standard that more and more consumer markets are taking into consideration, and these considerations also apply to economies such as ecotourism, as discussed by capacity trainer for projects like the Red Sea project. And it offers up multiple avenues for reinvestment in biodiversity gains, especially given the shifting capacity for global travel, and like any blue economy management strategies, there is much to consider in terms of conservation priorities. So our second action puts forward that these coastal ecosystems are co-managed by multiple reliant groups. And in New Zealand and the aforementioned Colombian example, there's a MPA, Marine Protected Area Framework, in place, and it points towards the need for strong sovereignty to underpin secure economic access and truly sustainable livelihoods. This contrasts against somewhere like Myanmar, for example, where sovereignty is not easily determined, which places limitations on co-management and highlights the need for recognition of things like bottom-up processes, engagement, discussion, and empowerment. And so this has to go beyond simple calls for change to true support, which shifts the power balance and realizes the benefits of co-management. And many instances, this is kind of an issue of justice and responsibility to some degree. So the Paris Agreement, for example, has a list of important stakeholders and covers intergenerational equity to provide along a strong legal framework on justice, which includes key stakeholders, locals, children, of future generations, so the people that aren't even born yet. However, the global actions are yet to align with this type of ethos. So for example, 92% of the emissions that come from the global north, whilst 97% of the deaths are attributed to climate change in the global south. And one of the key outcomes of COP26 was also this failure to send $100 million to the global south that they had committed to previously. So without financial support, many countries remain consequently capacity constrained. From a global perspective on blue carbon, protection is a much more important process than restoration. Our intact ecosystems, which are fewer and fewer in the world, they contain thousands of years of work, which attributes to carbon burial, for example. And if it is lost and released, it is possibly lost forever. So the idea that we can't go back is quite emotively illustrated by somewhere like Myanmar, where, you know, we had the capacity, we had the time to invest in this area. And when you don't take that opportunities, you know, life further down the line can't go back. So we were working there in 2016, which was a time of comparative political stability, and consequently it also came with hope for the remaining isolated spaces of biodiversity. So the area that I was working is Mymlajun, which is a wildlife sanctuary on the left there, and you know, at the time, and probably still, it's considered the last green space in the Myanmar Delta, for example. And so talking about action 3 here, which is to provide a wider and interconnected habitats, so networks that maintain and enhance biodiversity are implemented globally. So contests for resources, especially diminishing resources, has been a source of conflict throughout human history. Consequently, it's imperative to find means of protecting and maintaining the resources that can be implemented in a relatively straightforward way. And there's no silver bullet to this, but marine protected areas do help conserve resources under pressure, and they reduce a really important source of conflict. So effective marine spatial management is an important part of this, and especially if MPAs can be regionally adapted to remain relevant in the face of climate change. So this requires flexibility on the definition of a marine protected area in relation to, you know, aspects like marine biology, considering temporal and spatial scale, possible seasonal closures linked to reproductive cycles, geographic region and people, along with adaptability for social and environmental conditions. And a shift away from that narrow focus of spatial planning units towards spatial planning requirements that include additional mechanisms such as fiscal tools, ecological fiscal transfers, conditional cash transfers, or universal income, for example, were some of the options that we put forward. Among other payments for ecosystem services will be necessary to address the intrinsic value and need for conservation. So longer term, it's considered that linking the payoff to protected habitat may ultimately be a key motivator. So for example, it has been estimated that the global monetary value of benefits or ecosystem services provided by mangroves is $2.7 trillion annually. Here in the Falkland Islands, our kelp forest systems are estimated at $3.6 billion annually, and the Antarctic blue carbon is estimated at 2.27 billion. And so these estimates will likely increase in value, especially when these systems like the Falkland Islands, where kelp forests are abundant and almost pristine in nature due to their isolation and limited human impact, and Antarctic blue carbon, where sequestration capacity is increasing. So in combination with putting forward an avenue for carbon accounting in the future and an economic value of blue carbon, some of the key aspects of blue carbon from an ecosystem point of view link policy informed by science and build a case for biodiversity protection. And so if we protect them now, whilst their economic value is unrealized in terms of fishing and mining interests, for example, their true value is protected as economic and environmental circumstances change in the future. Action 4 is a decision-making equitable and based on ecosystem services. So we put forward in our paper that a key human psychological driver is a sense of fairness, and supporting good resource use and equitable distribution diffuses multiple sources of conflict. So this requires developing wealth mechanisms that support sustainable use, conservation, and management of coastal resources, and recognizing that normally termed developed and developing nations will have different pathways towards this end. So for example, individuals in richer nations need to constrain economic consumerism, conceptualizing it in terms of sufficiency and in fulfillment of the Sustainable Development Goals. At the same time, responsibility and benefits need to be shared and adequately resourced and funded. So, for example, in New Zealand, by working with Maori, actions by marine management, such as using terms like ocean guardians, show that such transitions can be done without crippling economic outcomes or degrading quality of life, but they rather improve it and create business models around things driven by long-term ethics of guardianship and care, which is embedded in Maori commercial and social activity within sustainable ecosystem processes to support integrated management of marine ecosystems and economies that include societal well-being and a fair and equitable distribution of resources. Okay, action 5. The knowledge of the marine realm is strengthened. So we called this mapping the ocean of life. And taking from psychology again, there were 2 important sources of conflict. So a feeling of deception or suspicion that arises when working in an information deficit, and the unconscious assumption that everyone holds the same knowledge and understanding as you do. And thus a disagreement is because they are being unreasonable, not because they have a different knowledge base to draw upon. So access to solid and transparent information provides the capacity to exchange information, and as a consequence, de-escalates conflict triggers. So linking capacity building and the provision of sustainable livelihoods is recommended here. And there are multiple decade actions kind of towards this end. And in the context of my geography and research focus, I put forward here the Challenger 150, which is a decade to study deep sea life, which has the South Atlantic working group composed of multidisciplinary, multi-partner networks of deep sea specialists working across the South Atlantic. There's also other initiatives like the Deep Ocean Stewardship Initiative, the Southern Ocean United Nations Decade Action, for example, and on the right there, I put in the One Ocean Hub, which has a very global focus. But there's a number of them in here in terms of making sure to link with multiple knowledge bases like natural history museums, universities, and more broadly as well. And we kind of have a lot of that collaborative capacity out there as a consequence of the Ocean Decade coming together as well. And so from here, we have what is, for our paper, considered the sixth action. And all of these actions are synergistic and need to co-occur, for example. So the interests of diverse user groups are balanced with a fair distribution of benefits. So as noted, a lack of fairness causes conflict, and consequently distribution of benefits, so not just resources, is needed to reduce conflict and support sustainability. And such approaches should coincide with both recognition of non-market values of coastal ecosystem services and access to them, as well as global schemes which provide support for transitions to sustainable practices and recognise that developed nations hold more responsibility in this regard and could contribute to less wealthy nations, for instance, by paying communities and local governance structures for conservation of natural resources. So in a Saudi Arabian context, it's considered one of the top 20 richest countries in the world. And so a shift in economic priorities towards investment in biodiversity and benefit sharing could be truly world-changing. And in the context of some of the research before this presentation, I sort of looked into, because there has been so much emphasis on the Ocean Decade and collaboration and multidisciplinarity. And, it's kind of, we already have a lot of the groundwork is done. And so this paper here, it looks like it already provides a well thought out framework in place, including the actors and the benefits to doing so beyond environmental factors assessed by a multidisciplinary team of global experts, for example. More broadly, in conclusion, these are global issues. And so the key takeaway from the work that we were doing is that by confronting issues of concern, such as economic structures that prohibit conservation, the possibility of achieving agreement on common ground can be facilitated. And this requires targeted financial support mechanisms that include wealth distribution mechanisms that support sustainable use, conservation and management of resources. So the recommendations towards a sustainable future that we identified through the lens of our coastal case studies highlight the need for place-based solutions adapted to the conditions of each community. And so it is my hope that in presenting this work to you today, that there are broader themes that can be adapted to a Saudi Arabian context in your working groups in the future. And there is also a general feeling, as so many of these groups come together and come to similar conclusions. So for example, within the Future Seas project, we had multiple challenges, multiple different groups, but the themes, especially things like the benefit sharing, were a consistent theme across all of the challenges. And as we enter 2021, there is this huge momentum to collaborate, and the capacity is there across the Ocean Decade. But what is missing is largely that targeted financial resourcing and targeting it specifically towards biodiversity conservation and the people who directly rely upon it as well. Thank you. That was my presentation, and I really appreciate you taking the time to listen.
Thank you, Dr. Narissa Bax, for on potential blue economic concept for Saudi Arabia based on your case studies. This potential blue economic concept and this action items that you have described here would be very helpful in Saudi Arabia to move in a blue economic path for the sustainable use of ocean resources while preserving the health of our ecosystem. Now the floor is open for the questions. You can either ask the question by writing your questions in the question and answer chat box or by raising your the hand option. Yeah, there is a question from Dr. Moritz. Dr. Moritz, please.
Yeah, all right. Thanks, Narissa. Thank you very much for the nice presentation. So my question is regarding the Arabian Gulf and the Red Sea. They're quite shallow basins, both are not shallow, but small basins, and bordered by a number of countries. So in our case, I guess national cooperation will be a big item to go towards the blue economy. And I was wondering if you have on the international scale, like any good examples for more like multinational cooperation on the concepts of blue economy.
I mean, what I often end up drawing on when talking in that context, you know, we come from our bias of where we've been, and so I have a quite solid Antarctic background at this point. I've been working in Antarctica for about 12 years, and something that has often felt very hopeful. Of course, there's challenges, but that you have those key attractions of very unique ecosystems that have societal value across the board, and you already have this really unique governance system which is collaborative and has been in place for a long time. You have the mechanisms behind that, and you have accountability. So of course there are issues there, but it does, in terms of the world that we have, provide a model for working together long term and developing, you know, practices around sustainability and accountability and consensus across nations, which is a very hard thing to do. And we do see it every year when marine protected areas come up for redesignation in Antarctica. But at least, you know, everyone's coming to the table and the conversations are there and the framework is there. So it, like you say, a lot of it comes down to national political will to work together effectively.
Thank you. Any other questions? Yes, Dr. Lin has a question. Dr. Lin, please proceed.
Hi, thank you for the presentation. I have a quick question. What are the most difficult challenge for the three studies, the three cases you are facing, and what is possible way to solve these challenges, and how this new solution can give us some lessons for in Saudi Arabia?
Yeah, so something that I'm, you know, feeling in my context of working from a developing nation example for Myanmar, you know, a lot of what was really highlighted from that example was the need to prioritize people, the need to alleviate poverty, the need to put financial mechanisms in place. And then, you know, there's also very grand issues of equity and legacies of conflict. Whereas in New Zealand, there, you know, we have some of those foundational things in place already. So there's a huge capacity and collaboration to work with Maori stakeholders, for example. Then those experiences have placed me in the Falkland Islands, where we are in the process of, after many, many years of work, so starting in 2014, there was an emphasis on marine spatial planning. There was a designation of potential marine protected areas. And these marine protected areas have some aspect of use. And so the framework that we have put forward is to kind of, it's like a freezing mechanism. So to adapt into each national context. And so that means that these are, rather than termed marine protected areas, they're termed marine management areas. But they sort of, once those hopefully are implemented next year, you have that foundation that you can work with and go from there and define marine protected area planning, for example, and you can start monitoring and looking long term. And so it's my hope that what we can do is incorporate aspects of blue carbon into that long term. And because we are such a, that focus on unique, isolated, biodiverse locations, which are rarer and rarer in the world, we have that opportunity, hopefully, to do something really meaningful.
Thank you.
So I think what I'm saying is to remove remove as many barriers as you can, and have the legal framework and have the governance in place and the high biodiversity, and it sets you up with a better chance.
I see. Thank you.
I think there is no more questions. If you have any more questions, you can contact the speaker by the email address.
Dr. Rommel has a question. Abdurrahman also.
Good afternoon. Thank you, Dr. Narissa, for the very interesting presentation. You mentioned about carbon credits. Are you familiar, or can you say if there are already carbon credit system established in Saudi Arabia or in the GCC, or if there's none yet? Could you suggest a possible carbon credit system here that can be implemented?
Yeah, I mean, I think that especially for blue carbon, the field is quite wide open. You have some of depending on what habitat you're looking at as well. So for the blue carbon work, for example, it's a little bit harder to incorporate that because we don't have the easy measurements across large spatial scales. But if you have ecosystems like seagrass and mangrove and salt marshes, then there's quite defined protocols to follow that are coming out. So the one that I put forward was the Vera methodology. So you could look into applying that in the context of Saudi Arabia. And then I think the thing to consider as well is, what the consequence of that financing is going towards. So the only example that we have functioning by that method is the Colombian example at the moment. And there's that very clear, community managed, the benefits go to the community, whereas Saudi Arabia might be quite a different context in terms of figuring out what is the most equitable way to do that and work with people towards that end.
And do you think that carbon credit system here, if applied, would it become a national level or only in Saudi Arabia, or can be applied interregionally or within the region among countries?
Yeah, I mean, that's a really interesting one to navigate, right? I think that's the big thing that came out is that we have more aspect on a national scale, but we're entering this time where we have a very real global issue to consider. And so whether the money is needed elsewhere, and I guess that was probably one of the key aspects of my talk, is that we have, we have countries in the world that are in desperate need, and it might be more beneficial to think about providing those benefits and offsets in a meaningful way in developing countries.
Thank you for the wonderful question.
Yeah, there will be a last question by Dr. Abdurrahman, because we have 2 more minutes remaining in our session. So Dr. Abdurrahman, please.
Yes, thank you, Dr. Narissa, for your nice presentation and very informative. But I am wondering how the comparison, the case studies between 2 countries. One is democratically, failed and facing many issues, Myanmar, another country, New Zealand. So this is rather easy to implement the actions in New Zealand. But the social issues in Myanmar, how far, what struggling, how much you struggle to study these case studies here. And the second question, most important, do you come across marine spatial planning in any of the countries? Like one area for a particular area is allocated permanently for aquaculture, other area for industry. So in Arabian Gulf, this marine spatial planning is a very, very important factor to be considered to enhance blue economy. Thank you.
Yeah, so it's a very fair point, and I think especially because things changed quite dramatically after the paper came out. So New Zealand continues to have that foundation and that collaboration, and what would be, considered quite good, equitable governance. And so not everyone can meet that standard, and we very much recognise that. And I think the dichotomy of those case studies was chosen just because the paper needed to be global in its scope, and figuring out a way to do that, but to also do that ethically, where we had some insight based on the expertise within the team as well. And so for Myanmar, especially now, it seems really imperative that more of the focus goes on supporting the work that is being done in that country. So people like working for NGOs to continue the on-the-ground work. Talking to my collaborators over there, they are still doing their best in very extreme circumstances. And yeah, I guess there's a huge hope that things will change there, and especially with ecosystems like mangroves and blue carbon, it does seem like there should hopefully be some capacity. In terms of the marine spatial planning, so that is a key focus for the work that I'm doing in the Falkland Islands, and so that has been a process of ongoing multiple years, and we are hoping to, throughout the time of my contract, which literally just started, to define ways of incorporating genetic connectivity, ideas of blue carbon and our understanding. And so some of the work that I'm doing at the moment is to look at the Burwood Bank, which is an offshore area which has a MSC certified fishery in that area, and we have done, based on the setup for Antarctic blue carbon, we are using that method to look at the amount of potential amount of carbon sequestered in that environment. And so once we get those sort of baseline understandings for these areas, the hope is that we can monitor and protect them long term and navigate this, it's a global issue, figuring out how to incorporate this into the management of our biodiversity ecosystems.
Thank you for the questions, and thank you for the detailed answer, Dr. Narissa Bax. If you have any more questions, you can contact the speaker by the email that has provided in the chat box. Now, I would like to thank Dr. Narissa Bax for accepting our invitation to attend this program, sparing her valuable time to prepare and present this very informative time. Thank you very much, Dr. Narissa Bax.
Thank you so much. I appreciate the opportunity.
Thank
Bye
you
for
very
now.
much. See you next time. Okay, the next speaker in this session is Dr. Robert Parker, a senior coordinator in Greenhouse Gases Emission Aquaculture Stewardship Council. Dr. Robert Parker is going to deliver a talk on environmental performance of blue foods, a very important topic in the context of blue economy. Dr. Rob Parker is the senior coordinator for greenhouse gases at the Aquaculture Stewardship Council, where he is developing tools for measuring and managing greenhouse gas emissions in aquaculture production systems and supply chains. Dr. Robert Parker has previously worked for energy use, greenhouse gas emissions, and other environmental impacts for fisheries and aquaculture systems in academia, as a consultant with producers, and in collaboration with industry groups and non-governmental organizations. His PhD studies at the University of Tasmania produce an overview of current understanding of fuel inputs to global fisheries and an estimate of the carbon footprints of the global marine fishing industry. Dr. Robert Parker co-manages a database of fuel input to wild capture fisheries called a fisheries energy use of database. By this short introduction, I welcome Dr. Robert Parker to this technical forum and request him to present his talk. The floor is yours now, Dr. Robert Parker.
Great, thank you very much. And thanks for the invite to speak to you all. I'll start sharing my screen here if I can to get going first, but I do want to to say how much of a pleasure it was to see Dr. Bax's presentation. Narissa and I studied our PhDs together at the University of Tasmania a few years ago, and I haven't seen or I haven't had an update, I guess, on a lot of the work that's been coming out of colleagues in Hobart in a while. So it's great to see that update and to see the work that you're doing, Narissa. And it's also great to see that there's so much interest in carbon and how this idea of a blue economy and blue carbon can contribute to the very important work that we're doing to combat climate change and to combat all kinds of environmental challenges. There's a lot of excitement right now, I think, after the COP26 meetings in Scotland, and governments are talking about this and industries talking about this. But I think there's also just this trend in the last few years where people are very much realizing that action is sort of needed now more than ever. And money is starting to flow into the right places to actually get that action moving. So it's great to see that there's so much interest in this and so much recognition of that incredible challenge before us. I was invited to talk today on the environmental performance of blue foods. And this is coming out largely from a paper that was published recently in Nature, led by a colleague of mine in the United States named Jessica Geffart. Trying to ask the question, if we have a world where we need to feed people, where there's demand for high quality animal protein products in people's diets, and where fish and shellfish are increasingly recommended as sources of high quality food for people, how does that fit in a world where we know that there are limits on our resources and that there are limits on the capacity of the planet to assimilate our wastes and to provide us with the things that we need? How can we sort of guide a sustainable seafood industry into a future that needs to be lower greenhouse gas emissions, lower carbon systems, that needs to emit fewer chemicals and toxins into our environment, that needs to release fewer nutrients into our water bodies, that needs to rely less on resources of land and water? And where do seafood systems fit in that context when we compare it to other types of food production systems? So land-based production of chicken and pork and beef. How do seafood systems compare to those systems? Is there an opportunity here for seafood systems to provide a lower impact product compared to some of those land-based alternatives? So that's what I'm going to talk about today, and I'm largely going to split my time, I think, between talking about fisheries and fuel consumption in fisheries, which is where a lot of my own work has been focused, and these broader challenges of environmental performance and environmental thresholds and how seafood systems fit within them. So I don't think I need to really introduce the concept of global warming and the concept of climate change for this audience. I'm sure it has come up a number of times. But it's certainly one of the key aspects of environmental performance that we look at in our work. It's not the only one. If you remember back in 2009, the work put out by Johan Rockström and his colleagues from the Stockholm Resilience Institute on planetary boundaries and this concept that there are limits to the ability of the planet to provide us with the resources that we need and the capacity of the planet to assimilate the wastes that we produce, and that includes wastes of greenhouse gas emissions. And even before that, there was similar concepts. So the concept of the ecological footprint put forward by Bill Rees and Matisse Wagernagel, this idea that there is a certain amount of space on the planet that can provide us with what we need, and each of our activities takes up a certain amount of that space for whatever activities are required to underpin it. And at a certain point, then you reach sort of that maximum amount that a sustainable planet can provide, and then beyond that, you say we need 1.2 Earths or 1.5 Earths or 2.2 Earths to support the activities that we're undertaking. And before that, there was similar concepts of phantom planets and ghost acreage, and this understanding that everything that we do has some impact that's beyond just what we see on the ground. There are upstream and downstream systems that are engaged in this. And so that's the general idea here that we're working within, is that we have these thresholds, we have these limits on what we're able to do sustainably within our environment. And we need to be able to quantify how much an activity or a product that we use or a practice that we undertake, how much that contributes to us moving towards those sustainable limits and ultimately passing them. So going back to greenhouse gas emissions and climate change, because this is the one that I'm going to talk about the most, this is just a quick couple overviews from a few papers here. One is the idea that food systems, being everything that's required to produce and process and distribute the food that we eat, account for somewhere between 1/4 and 1/3 of global greenhouse gas emissions. And there are indications that is increasing. So as other sectors of the economy, like energy production and transport, become more efficient, and we can achieve more with less greenhouse gas emissions, food production seems to be moving somewhat in the other direction, that it's accounting for a larger and larger portion of total global emissions over time. And that may be for a few different reasons, but it's certainly driven by a growing global population and a growing affluence of that population and demand for high quality animal protein products. And we know that the vast majority of the greenhouse gas emissions associated with global food production systems are associated with those animal protein production systems. So beef production and the methane emissions from enteric fermentation in their rumen stomachs, the production of feed to support livestock and poultry and aquaculture, the deforestation of land to grow some of that feed, deforestation of land in Indonesia to produce palm oil, or deforestation of land in Brazil to support soy production, ultimately to feed animals and then to feed ourselves with those animals, or to graze animals. Large swaths of land needed to be cleared to support beef production simply for grazing. We know that animal protein production drives not just greenhouse gas emissions, but it's a large driver of water consumption. And it's a large driver of land use. If you look across the landscape at the amount of arable productive land that we have, a large portion of that is used to produce animals. So where does seafood fit in that picture is the question that we come to then. And that's where most of my work has taken place, is within that context. And the tools that we use to answer that sort of question is called life cycle assessment. This is an ISO standardized framework. It's often associated with the terms cradle to grave or cradle to gate, this idea that you can look at the life cycle of a product or the life cycle of an activity or a process and say, what is everything required to provide that product to consumers? So if we're talking about a food product, perhaps we're saying, what is the impact of a kilogram of meat or a kilogram of protein or a certain amount of caloric energy? What are all of the inputs and outputs upstream in that product's life cycle? needed to underpin the provision of that to a consumer. So this starts with the extraction of raw resources. It moves through to the processing and refining of those resources, to the packaging of them, the storage of them, the energy requirements for all of those processes, up to the point just where you have a product ready to be consumed, and then you need to distribute it around the world. If we're talking about fisheries and aquaculture here, we're distributing them more than most products are. They're one of the most traded commodities on the planet. And then they need to be moved around and sold by wholesalers, sold by retailers, stored in retail stores. They need to be purchased by consumers. They need to be transported back home or perhaps to a restaurant. They're prepared, they're cooked, and every stage of that life cycle then carries a certain amount of impact. So when we're asking a question, how much greenhouse gas emissions is a fishery product associated with, or how much land use is an aquaculture product associated with, or how much water is required to support the production of a liter of milk, we really have to take what's called this life cycle approach or life cycle perspective and understand what all of the inputs and the outputs are throughout that entire supply chain. And then we can translate those flows of material and energy through the supply chain into contributions to each one of what we call impact categories. So the impact category of global warming potential or climate change is all of the greenhouse gas emissions at each of these stages of production added up. And for fisheries, you can see in the gray circle here, what's included in that outside of the usual stages of processing, packaging, transport, etc. There's particular things that we know are important to fisheries. So fuel consumption, how much fuel is burned by a fishing boat, the provision of bait for some fisheries, so for tuna fisheries or for lobster fisheries, where is that bait coming from? If it's fish, how is that fishery undertaken? How much fuel is required in that fishery? How do we manufacture the gear? How do we produce the vessel? What sort of refrigerants are used or ice? And if it's ice, where does the energy come from to produce that ice and so on? And each one of those inputs also has its own life cycle and its own story that we need to incorporate into these models. So we look at just what has been done around the world and published. There's around 100 studies that have produced models of fishery or aquaculture products and followed their life cycles to quantify all of the inputs and the outputs to each of their stages of production and translate those into one or more environmental impact categories. And we see that over time, this has increased quite a lot. So it was only beginning in around 2003 or 2005 that we started to see the first studies quantifying some of these environmental impacts from seafood systems. And now we have these roughly 200 case studies and many more case studies of livestock systems and of agriculture systems and of horticulture systems. Importantly, though, each one of these studies has its own audience, it has its own motivations, and those motivations influence what the scope of the study is, they influence what the methods of the study are. So it's very difficult sometimes to compare study to study and determine that one product has a greater impact than another, because the approach that each study takes is really determined by the scope and the objectives of that study. So you may have a study asking the question of perhaps it produces chocolate. And they want to know if there's a lower greenhouse gas impact of their chocolate production, whether they get their cocoa beans from one country or get their cocoa beans from another country. And so they may look at, well, what are the rates of deforestation associated with cocoa production in different countries? Or what are the energy inputs to the processing of those cocoa beans and so on. Or you may have another study that is particularly interested in packaging of products. So maybe they have sardines and they're wondering, is it more efficient to package these in a steel tin can or is it more efficient to package them in larger frozen blocks? And then how do you transport and distribute those products then? So there's all sorts of different reasons why a study may undertake this. But at the end of the day, we come out with an idea of what are the greenhouse gas emissions or other environmental impacts associated with some product in some form from some sort of system. And for our purposes, some sort of fishery or aquaculture system. There's a challenge here in that the research that we've undertaken as a field of study in life cycle assessment has largely been driven by Europe and somewhat less so in Australia and North America. And we're really just beginning to get a better sense of what some of the environmental impacts are in less developed countries and in many regions of the world where there's a lot of food production, but there's just less of that research capacity or less of that communication of research that is being undertaken. So we see in the top here, this is the countries where aquaculture life cycle assessments have been conducted. And we can see that it's very much driven here by European countries. So there's a lot of salmon life cycle assessments. We're very good at understanding what are the inputs to a salmon marine net pen system. There's a fair bit of work that's been done on rainbow trout. There's quite a bit of work that has been done on shrimp production in Asia. But there are large swaths of global aquaculture production that we simply don't know very much about, and that's particularly production in China. We just don't have a great idea or understanding of what are the energy and material inputs to those production systems. And likewise, in fisheries on the bottom here, you see a very similar sort of distribution. You have a lot of fisheries research that has been done in Spain and in the United Kingdom and in Norway and Sweden, but fairly little research in many of the other large fish producing regions of the world. And it's really just been more recently that we've started to get an idea even of some of the very important fish production regions in on the west coast of South America, where some of the largest fisheries in the world are. So we're slowly expanding our understanding, but we are quite limited here. And that's sort of a theme throughout a lot of our research, is that there's this bias towards more developed countries and more industrialized fisheries. And we sort of have to assume that the patterns that hold in those regions are going to hold elsewhere as well. And this is what some of those patterns are. So we look at wild capture fisheries and we say, well, based on the research that has come out, what are the big drivers of greenhouse gas emissions in wild capture fisheries? We see that about 60 to 90% of the emissions are associated with the fuel consumption on board the fishing vessel. There is also a few other sources of emissions, being the use of some types of refrigerants, that production of bait. There's some recent research that's come out to suggest that bottom trawling may have quite a large carbon footprint impact. This is from both the kicking up of carbon into dissolved carbon in the ocean, but also disturbance of the ocean floor, like Dr. Bax was referring to, that very productive ecosystem on the ocean floor, if it's disturbed, can have quite a carbon impact. And then past that point of landing, there's also the potential for a lot of emissions in distributing fishery products, especially if they're put onto an airplane, like some products are. Thinking particularly about bluefin tuna or lobsters and crabs, these relatively high value products that more commonly get flown so they can be delivered and sold fresh or live. And for aquaculture, there's a certain different set of drivers of greenhouse gas emissions that we need to look at. So there's still that role of fuel consumption and electricity consumption, especially in some systems, like a recirculating aquaculture system can use a lot of electricity to support their temperature regulation and their waste removal and all of the services that would otherwise be provided by a lake or by an ocean. But there's also the production and the processing of feed. Where that feed comes from is very important. If that feed is associated with land use change, so again, soy production in Brazil, or if that feed is associated with high greenhouse gas sources like bovine meal from beef or from dairy, or some potentially high energy, high fuel use fisheries providing products that feed into aquaculture feeds. There's also biogenic emissions to take into account. So these are emissions from fish ponds and from fish themselves. And again, once you reach that point of the farm gate and you're trying to get that produced fish or shellfish product out to a consumer, some products are put on an airplane and are transported around the world by air to be sold fresh or live. And again, that carries quite a large impact as well. So providing a little bit of an overview of some of the results that we've had for fisheries and for larger seafood production systems. This is a paper that came out of the work that I undertook with colleagues in Tasmania on just how much fuel do fishing boats burn and what are the greenhouse gas emissions associated with that. So we were asking how much fuel does it take to catch fish? How does that vary between fisheries and what drives some of that variation? Is it the size of vessel? Is it what they're targeting? Is it fish behavior? Is it the behavior of the fishermen? And how do fisheries then contribute to the overall greenhouse gas emissions of food production systems? And how does that vary by country? And some just general conclusions we came to in terms of quantifying these fuel inputs and quantifying greenhouse gas emissions. For the roughly 81 million tons of fish and shellfish that were landed by wild capture fisheries in 2011, it took 40 billion liters of fuel to catch it. That sounds like a whole lot of fuel, but it's not necessarily a lot in the context of how much energy is required to support larger systems globally. It produced about 180 million tons of carbon dioxide equivalent greenhouse gas emissions, which again is a very large number. It's hard to sort of visualize what that means. To put it into context, it's roughly the same carbon footprint as the country of the Netherlands. So that one country produces around 200 million tons of carbon dioxide a year, and that's equivalent to the carbon footprint of the global fishing industry. And once you bring that down to the level of a fishing product, live weight at the dock, roughly 2.2 kilograms of CO2 equivalent per kilogram of fish or shellfish. And that's the average across all fisheries, but it varies quite a lot. So we can see here, this is the pattern of fishing landings. So just what is being landed, live weight production of global fisheries. Again, up to the year 2011, but starting here in 1990. And it's divided by a few different species groups. So we see that a large amount of production is made up of what's called small pelagic fish or forage fish. These are small schooling fish like anchovies and sardines and herrings. A fair amount of production of larger pelagic fish. So that includes the tunas and some large mackerels. Quite a bit of production of demersal fish. That's where all of your cods and your hakes and your haddocks fit. And a relatively small amount of production year after year of demersal mollusks, cephalopods, and crustaceans. This is just the production of live weight mass from global fisheries. But if we say, okay, let's take the same species groups and look at what the trends are in their fuel use and their greenhouse gas emissions, how does that look? And we get a very different picture. So on the right here is the greenhouse gas emissions. Now, globally, the aggregate emissions of the global fishing industry divided among those same 6 species groups. So we see that the small pelagic fisheries that accounted for quite a large amount of production account for almost a negligible amount of the greenhouse gas emissions of global fisheries. That's because we can go out and fish anchovies and burn roughly 20 liters of fuel and catch a ton of anchovies. It's a very efficient fishery. Or you can go out and catch Atlantic herring and burn roughly 100 liters of fuel and catch a ton of herring with a mid-water trawl or with a purse seine. But you see quite a bit more emissions coming from the larger pelagic fish and the demersal fish. So if we get up to, say, Atlantic cod fisheries with bottom trawls or with hooks and lines, we're starting to look at more like 500 liters of fuel to catch a ton of cod, or 600 or 800. Some tuna fisheries, so skipjack tuna that we find in cans a lot, we're looking at more like 400 or 500 liters of fuel to catch a ton of skipjack tuna. For some of the larger tunas like big eye and bluefin, we might be looking at more like 1,000 or 2,000 liters of fuel to catch a ton of tuna. And then if you look at the orange bars here, probably the most dramatic change is the crustacean fisheries. And this is where we start to see fisheries that have a relatively low amount of catch, but a very high value and a very high amount of fuel use underpinning that catch. So we see some lobster fisheries in Australia that burn 3,000 or 4,000 or 5,000 liters of fuel to catch a ton of lobster. We see some lobster trawl fisheries in Europe that might burn 10 or 12 or 14,000 liters of fuel to catch a ton of lobster. That's up to 14 or 15 liters of fuel for 1 kilogram of lobster, really one animal. This varies quite a lot. Not all crustacean fisheries are going to be that intensive. If you cross the Atlantic and you look at the lobster fisheries here on the east coast of Canada and on the east coast of the United States, you're going to find some lobster fisheries that only burn 1,000 or 800 liters of fuel to catch a ton of lobster, compared to the 3,000 or 4,000 in Australia, or the 2,000 or 3,000 in New Zealand, or the 10,000 or 12,000 in Europe. So there is a lot of variation within these groups, but these are the big patterns that we see by species group, is that it takes a lot more fuel and a lot more greenhouse gas emission to catch a crustacean, like a shrimp or a lobster, than it does to catch a herring or a mackerel or an anchovy or a sardine. If we see how this plays out globally, this is a map of the overall greenhouse gas emissions by fishing country of global fisheries in 2011. We see that most of the fishing emissions are coming from Southeast Asia and China. This shouldn't be a surprise. That's where most of the fishing is. So this is really a reflection in large part of global fisheries and landings. So it's not a terribly interesting map, in my opinion. This is more interesting. This is dividing that greenhouse gas emission value for each fishery or each country by how much they land. So for every ton of fisheries production in a country, what is the carbon footprint of that average ton of fisheries production? And then you see a very different picture from the previous map, and you can start to point out some interesting patterns. So if we look at Australia, it ends up being one of the most greenhouse gas intensive fisheries on the planet. Why is that? It's because they're focusing largely on catching these high value but high fuel use species. So there's a lot of crustacean fisheries in Australia, a lot of shrimp fisheries, and a lot of lobster fisheries that require a large amount of fuel to catch them and produce a lot of greenhouse gas emissions. When there's relatively little, there's certainly still lots of the smaller, small pelagic fisheries and the more efficient demersal and large pelagic fisheries relative to other countries. If we look at the other extreme, we can look over to the west coast of South America and find in the upwelling zones here the large fisheries for Peruvian anchovy or anchoveta. And this is that fishery that goes out and burns 20 liters of fuel to catch a ton of anchovies. So this is the other end of it. This is the most efficient fisheries on the planet and by the country. Unfortunately, a lot of those anchovies don't actually get eaten by humans. They get used for other purposes, including production of aquafeeds. But is one of the most efficient sources of animal protein on the planet, if we can convince people to eat more of that rather than sending it through other systems, it may be one of the better ways to feed people a high quality protein diet. And then this map looks at what are those greenhouse gas emissions from fisheries relative to larger food production systems. And we can see that for most countries, a very, very small percentage of the overall greenhouse gas emissions from food production is associated with their fisheries. And it averages out to about 4% of global fishing or global food production emissions associated with wild capture fisheries. But this is a bit higher in some countries that you can see the darker blue countries here. And these are the countries, smaller island nations and some coastal nations that rely more heavily on fisheries. Maybe they have a larger fishing industry like Japan and Norway, and then end up having 10, 20, or 30% of the emissions associated with their domestic food production are actually coming from wild capture fisheries. So that's the picture for wild capture fisheries. But if we expand out to all of seafood production, and if we go beyond just greenhouse gas emissions, that brings us into the recent paper that Jessica Geffert led, now published in Nature. It was getting at this idea of environmental stressors, and back to that idea of these sustainable limits or these thresholds beyond which we don't want to exceed, and how do seafood systems contribute to those environmental stressors? How do they compare? What drives them? And what measures might we be able to implement to make sure that seafood systems fit within those sustainable limits rather than surpass them? So for that paper, we had really 4 different, what we call environmental stressors that we were interested in. One was certainly greenhouse gas emissions, because that's what a lot of people are very interested in right now. And it's where we have a lot of the best modeling and the best data available to support the measurement of them. So that's the full life cycle greenhouse gas emissions of a seafood product. It includes the fishery and all of the inputs to the fishery, or for aquaculture, the farm and the upstream feed production to feed fish if necessary. And we communicated in terms of kilograms of CO2 equivalent or carbon dioxide equivalent emissions per ton of edible product weight. And for each one of these environmental stressors, we're ultimately getting at what is the impact per ton of edible weight. The second environmental stressor that we looked at is called eutrophication. This is the contribution to nutrient loading in water bodies, so that could ultimately contribute to issues like algal blooms. And this, we measure the output of nutrients, including nitrogen and phosphorus, and we communicate them in terms of kilograms of nitrogen equivalent amounts or phosphorus equivalent amounts. The third environmental stressor that we looked at was the consumption of fresh water. And this includes both the direct input of water as well as the indirect requirements for water upstream in, say, the production of feed. And for the direct requirements of water, a lot of this is associated with pond systems, and a lot of the measurement of it is driven by evaporative rates. So looking at the loss of water from pond systems, depending on what sort of environment it is, and how quickly that water evaporates, and water is then needed to replace what is lost. And then the final environmental stressor here is land occupation. So again, we're looking at both occupation to support the farm site itself, but also upstream in that feed production process. And this is communicated in terms of a square meter or square area of land equivalent to the occupation for 1 year. So if you have a kilogram or a ton of edible product weight, how much land is required to be occupied for 1 year to support all of the processes in the life cycle required to underpin the provision of that product. So those are the environmental stressors that we looked at, and this is what some of the results look like. So for each of these, then we divide up between different types of seafood systems based on the species here. And we can see how things vary in terms of here the greenhouse gas emissions, but we also put it in context of larger food production systems here by providing an indication of where chicken fits. And then there's going to be a chicken value for each one of our stressors, because we very much want to put these seafood systems into that a larger food production system context, that we don't just have seafood in isolation. There are other systems that we need to understand. Are we higher than them? Are we lower than them? Is there an opportunity here to increase or decrease the impact of a diet or a global food system by shifting production between seafood and chicken or beef or pork or whatever system we're looking at? So compared to chicken, we can see that the greenhouse gas emissions of here on the top farmed systems actually vary quite a lot. Some systems producing edible product yields at a much lower greenhouse gas cost than chicken, and certainly a much lower greenhouse gas cost than other livestock systems like beef and pork. But you don't see that it's consistent across all species groups. And there are some types of aquaculture systems here that can be associated with very large amount of greenhouse gas emissions. And what drives that then is some combination of energy use, feed use, and then the production of that feed, and biogenic emissions, including emissions associated with land use change, either at the farm or upstream in the feed production. And we see a very similar sort of variation around that chicken average value for the wild capture fisheries. And here we again see that the lowest greenhouse gas products are those small pelagic fisheries, those herrings and anchovies and sardines. And the highest greenhouse gas fisheries are the crustacean fisheries, the lobsters and the shrimps, as well as the flatfish fisheries, things like flounders and halibuts. And then there's quite a lot of variation even within each of these groups then, that you may have, say, a cod fishery that has a very low greenhouse gas emission in one part of the world, and then another cod fishery in another part of the world that actually has a very high greenhouse gas emission associated with it. If we expand out, and this is just for farmed systems now, we didn't look at some of these other stressors for fish systems. But if we look at say, the eutrophication impacts or the fresh water consumption or the land occupation associated with farmed species, we see a similar sort of variation across different systems. So this tells us that not only do we have a wide variation in the impact associated with farmed seafood systems, but it's also quite inconsistent across different impact categories. So we can look at the greenhouse gas emissions here on the far left versus the eutrophication impacts or the land occupation. We can see that they don't always follow the same pattern. You can have a very greenhouse gas efficient farm system that's actually associated with a very unsustainable level of water use or of land use to underpin it.
Excuse me, Dr. Rob Parker. How
Yes.
many more slides do you have?
I just like 2 more, I think.
Yeah, okay, because you have two more minutes in the allotted 45 minutes.
Okay.
Thank you.
So I just want to give a quick overview from 2 other pieces of work that we've put out recently. One is looking at if we have this idea of what the greenhouse gas impacts of a seafood production system is per kilogram of live weight or per kilogram of edible weight, what does that mean in terms of the actual nutritional value of that product? Because we know that not all fish are created equal, not all shellfish are created equal. You might get a lot more nutritional value out of one product than another. So if we reimagine what the greenhouse gas performance of some of these systems is through the lens of nutrition, we get a picture like this, where we have again, a comparison here with chicken, pork, and beef with the letters C, P, and B here, and where different seafood systems fit around them. And we can see that a lot of seafood systems actually produce higher nutritional value for a lower greenhouse gas cost than some of these alternative livestock and poultry systems. So this was looking at the inputs to Swedish fish consumption. But if we look at this on a global scale, we'll see very similar patterns. And we have the potential here to provide a lot more nutrition with a much lower greenhouse gas impact from some seafood systems. But again, we need to identify what those seafood systems are that have the lowest impact. And the second paper that I want to provide a little bit of an overview here from is a report that was put out a couple of years ago from the World Resources Institute, looking at the contribution of different ocean-based activities to the mitigation of climate change. And our role here specifically was looking at seafood production, fisheries, and aquaculture. How could they actually contribute to the reduction of greenhouse gas emissions over time? And we found that it wasn't so much the reduction of greenhouse gas emissions within fisheries or the improvement of efficiency, say, on farms. It was the biggest opportunity here was for fisheries and aquaculture products to actually offset some of the impact of other food production systems by replacing those products in diets. That if we can replace a very high greenhouse gas beef product or a very high greenhouse gas lamb product with a lower greenhouse gas seafood product, that's where the biggest opportunity here is for reduction of greenhouse gas emissions. So there's just a few questions here that then I want you to think about to sort of put this into the context of where we move forward in terms of global food production systems in a sustainable and a carbon constrained world. So if we want to feed people and we want to do it with high quality protein products, but we want to do it in a climate friendly way, where does seafood fit into that? What does a future sustainable global food system look like in that world? And what sort of innovations and technological solutions then can help guide us towards that place? And thank you very much. And if you have any questions or comments, or you want to get in contact with me, my email is here.
Thank you, Dr. Robert Parker, for this very enlightening talk on environmental performance of blue foods. Saudi Arabia, with the Arabian Gulf and Red Sea on either side, has an immense role in utilizing the resources in a sustainable manner. Now the floor is open for questions. You can either ask the questions by writing your queries in a question answer chat box or by raising the hand options. Yes, Dr. Lin has a question. Dr. Lin.
Hi, Dr. Parker, thank you for interesting talk. I noticed that there are, in fact, in your presentation, there are two Gulf countries that are listed with like high emissions, which is first one is Saudi Arabia, which I guess it is because of the trawl fishery, I guess. Yeah, yeah, this one. In terms of color, it seems that the Saudi Arabia is as much as Australia. So can you elaborate on this one?
Yeah, so I will say I don't know very much about fisheries in that region of the world, because if you remember from a previous slide here, most of the data that we have are not from that part of the world. They're from other regions. So we have to rely on this assumption that the same patterns that we see in Europe and in Australia and North America will hold true for Saudi Arabia and for other Gulf countries. So the reason why we expect then a high fuel use and a high greenhouse gas impact from fisheries in Saudi Arabia is because of the breakdown of that fishery by species group. So there's a lot of those really high fuel use crustacean fisheries, higher fuel use trawl fisheries. And since we don't have data directly from Saudi Arabia, we have to assume that they'll follow that same pattern. They'll require similar fuel inputs to what we see for trawl crustacean fisheries elsewhere. So that's what's driving that higher impact there.
Yeah, I guess so. Okay, the second thing is that the Saudi Arabia, they are going to have a lot of investment on the aquaculture. Do you have any suggestion that which aquaculture what they are going to the aim is to double or to increase the aquaculture production in Saudi Arabia maybe in 10 or in decades? Do you have any suggestion that which direction that Saudi Arabia the authority can follow to reduce the greenhouse emission?
Yeah, if we want to have a low greenhouse gas aquaculture industry that doubles in production or that feeds a much larger population, we have to identify these lower input, lower greenhouse gas species production systems. So that's things like mussels and other bivalves that don't require feed to support them and can actually provide some ecosystem services through their own production. There's also a lot of opportunities in seaweed production and seaweed aquaculture. There's a lot of interest right now in how larger production of seaweed systems might be able to provide low greenhouse gas aquaculture products. And there's also quite a bit of interest right now in looking at sort of less conventional aquaculture systems. So things like multi-trophic level aquaculture systems, where you might be able to produce fish or shellfish with less input from outside sources. So less feed required because you have that trophic dynamic within your system itself. So there's some opportunities like that. We know that the intensive fed systems tend to have a large impact with their feed production, and that some land-based systems can potentially have a high impact with their energy use. And that some extensive pond systems can have a large impact associated with land use change. So we can know to avoid certain practices, but I would say that the biggest opportunities are around those low trophic level species, things like bivalves and seaweeds.
Oh, thank you.
Yeah, Dr. Narissa Bax has a question. Dr. Narissa?
Hey, Rob, nice to see you as well. And brilliant presentation. I had a few questions written down, but I was just wondering, maybe back at the beginning of the talk in terms of things like the life cycle, something that I became aware of moving to the Falkland Islands is the idea of your risk footprint. So just how much it costs to be prepared for something like an oil spill in a remote location. And we talk about it a lot in an Antarctic context too, because there's a huge footprint of working down there. And I just wondered if you had any considerations or knowledge about that as well.
I don't. It's a fascinating thing, and I really like the idea of applying this life cycle perspective to more than just the quantification of greenhouse gas emissions. That there's so many other impacts or other considerations that we could look at. I'm really interested in some of the social work that's going on around potential social impacts of fisheries or of aquaculture systems. In that life cycle perspective. So recognizing that it's not just social impacts on the farm, but it's also larger communities and upstream activities contributing to that. So I'm not sure if that answers your question really at all, but yeah, it's a fascinating thing to be able to look at a lot of the things that we've traditionally thought of in more isolated terms, but start to apply that life cycle approach to.
Yeah, I mean, I think you sort of built on what was going to be my second question there as well, in terms of, the multi-strategy approach. So when we were first talking about the blue economy and the Future Seas project, there were a lot of, decarbonisation actions were a huge focus, and there was talk about electrifying the shipping industry more broadly, and I wonder how much you know about the uptake of that for fisheries as well.
It'd be really interesting. I don't think that there's a lot of uptake on a large scale right now in fisheries. It would require, I think, a very large investment. There's a lot more interest, I think, in electrification for coastal aquaculture systems. There's a lot of work being done in Norway, I know, to look at electrification of aquaculture. But for fishery, I think it's a bit more of a challenge. But there are some interesting developments on things like sail-assisted fisheries or ways to reduce the fuel inputs to fisheries in that sort of way. So I don't think that we'll get to electrification of fisheries in the next 10 years or so, but maybe further into the future we will. But we'll certainly see it more in land-based production systems.
Yeah, and probably just a final question in terms of, it's quite a wonderful way to look at things globally, the way that you have with these maps. And, you know, some of the obvious gaps stand out as well for Antarctica, and it's quite interesting to see, you know, the Falkland Islands is very heavily economically focused on fisheries and tourism, so not a very diverse economy. And so, yeah, I just wondered if you had any slight insight in terms of, you know, you have a good data set there, but it seems like quite a lack for Antarctica.
Mm-hmm. Yeah, so there is one fishery that I assessed that's based in Antarctica, but the fishing country is actually Norway. So that's the Antarctic krill fishery, and that's another fishery that like the anchovies feeds into aquafeeds or other products that aren't necessarily human consumption products. So we have some data on the fuel inputs to the krill fishery. I can tell you that it works out to somewhere around 100 to 200 liters of fuel per ton to catch Antarctic krill. And there's also been a study done on Patagonian toothfish, and this was done by Sarah Hornberger out of Hobart. So there is a little bit of work that has been done in that region of the world, but again, most of the research is being driven by Europe and interested primarily in the products that Europeans are eating and the industries that European countries are engaged in.
Okay, thank you so much, Rob. Nice to see you.
Cheers, nice to see you as well.
Thank you for the question. Dr. Abdurrahman has a question. Dr. Abdurrahman, please.
Thank you, Dr. Berger, for your nice presentation. I observed that you used a very old data, 2011 data for, you know, fish catch, that is around 81 million tons. Now the fisheries production has almost doubled, around 179 million tons. So I am thinking how much will be the emission now. And the most important thing is when you assess the environmental stresses, actually I didn't find acidification of land by aquaculture, you know. Particularly marine aquaculture, when they start in some coastal area, there's always a problem with the acidification of land. This also enhance, you know, the carbonic acid in the land issue, making many environmental issues. So did you come across this acidification?
Yeah, just on your first point, I'm not sure where the number comes from for current fisheries production. Wild capture fisheries production has sort of been relatively consistent between 80 and 90 or so million tons per year, and there hasn't been a huge shift in what that production looks like. So I wouldn't expect production in 2021 to have a radically different greenhouse gas impact from what it looked like in 2011. And on the topic of acidifications, so terrestrial acidification is actually a fairly common impact category for life cycle assessments of seafood systems. So if you look at the actual studies, you'll find quite a bit of information on contributions to acidification. Not as much in that local context that you are talking about, but larger in that life cycle context. And it tends to be driven mostly by the same drivers as greenhouse gas emissions. So the production and the use of fuel and the burning of fuel and emissions into the atmosphere when you burn it. So there is some research out there then to support a similar sort of analysis of terrestrial acidification. I'm not sure how things would necessarily look when you look just at that local context for aquaculture and acidification, if things would follow very different patterns from greenhouse gas emissions or not.
Thank you. Dr. Morris has a question. Dr. Morris, this will be the last question in this session.
Yeah, okay. Thank you for the really interesting presentation, Rob. So I have actually two questions. One, where you showed the plot of greenhouse gas emissions versus like the quality of food. I think this was all from wild catches, right? Or did that include aquaculture as well?
That includes aquaculture as well. And it's not indicated here sort of which of these bubbles are farmed and which are not. But if you look at the red bubbles, is the salmons and trouts. So a lot of that is farmed production. So Atlantic salmon and rainbow trout. Some of the mollusk shellfish, so that light green, is also farmed production. The cod, hakes, haddocks, flatfishes, herrings, that would all be wild capture.
So from the previous paper on the greenhouse gas emission, you had really very low greenhouse gas emissions for aquaculture of shellfish and seaweed. But so where would these place in that plot?
So seaweed would be a difficult one to place it, because the nutritional value of seaweed is such a different thing than most seafood products, in that it's not primarily an animal protein source. It has a different nutritional sort of score. So I'm not sure exactly where it would fit in terms of the nutrition, but it would certainly be very low in terms of the greenhouse gas emissions. Perhaps not quite as low as the yellow bubbles here for the small flash fisheries, but down towards that end of things.
And so my second question was, we heard previously yesterday in some presentations on the aquaculture in Saudi Arabia that they're looking very much in like the applications of aquaponics. So like combining aquaculture with some growing from some vegetable in combination with the aquaculture. So have you looked into this, like what or how big the positive effect would be of this methodology?
It's a challenge, and I think it really depends on what sort of fish you're producing in that system, what sort of inputs are required for it, and what sort of setting you're in. So these are land-based systems that can require a large amount of energy to support them. And if they do require still inputs of feeds, there can be a lot of impact associated with those feeds. There's been a few studies that have quantified the impact of fish production in aquaponic systems along with vegetables. And depending on how you allocate impact between the vegetable production and the fish production, you can still end up with quite a large impact. So you really have to be careful about what sort of production system you have, what are the inputs to it, be quantifying how much energy is needed and how much feed is needed to support it, before you can sort of come to a conclusion that it will provide a lower greenhouse gas product.
Okay.
Yes, sorry, we cannot accommodate any more questions, as I think it's already we surpassed the time. But if you have any more questions, you can contact the speaker by the email that he has provided in his presentation, and also we are going to give you it in the chat box. With this, I would like to thank Dr. Robert Parker for accepting our invitation for attending this technical forum and sparing his time to present this very informative talk. Thank you very much, Dr. Robert.
My pleasure.
Thank you. See you next time.
Ashraf, you are muted.
I also thank all the attendees and other members for their attendance in this session. With this, we are ending this session. Now, we will commence the final session for the final discussion and closing remarks. I welcome Dr. Eugene Lin for coordinating this closing session. Thank you.
Hi, thank you, Ashraf, for the brief introduction. I'm the Dr. Eugene Lin. I'm going to make a summary concluding remark for all the presentation for the past 2 days. First one, we have a presentation from Katrina. He has summarized how a blue economy can be achieved in a resi company through a set of regenerative tourism practice. Both projects aims to achieve complete carbon neutrality and a 30% net increase in biodiversity. And the carbon neutrality can be retrieved by capturing carbon locally, and net biological increase will be realized by protecting, enhancing, and conserving the important habitats such as coral reef and mangroves. And second, we have Dr. Abu Baker, who gave us a summary about how the wind energy in the Arabian Gulf and the Red Sea. In the Arabian Gulf, he found that the middle region seems to be the best suited for the wind energy production. And he also mentioned that the class 3 turbines are suitable for wind energy conversion in the Arabian Gulf. And third one, we have the Papagale, who introduced us the role of aquaculture in Saudi Arabia's blue economy. And he thinks that aquaculture can be a high quality and efficient protein source. He also let us know that aquaculture can be an important pillar of economic growth of the kingdom. And third, and then we have Dr. Vivekanand, who has shown that fishery can be perfect fit into blue economy concept. That he suggests that blue economy implement by balancing economic development and environmental sustainability. Although in the schedule we have a FAFIT about the aquaponics, but unfortunately due to technical reason issues that he had to cancel the talk. Then we come to today's presentation. Now we have Dr. Hankel, who summarized the current status of the vegetative habitats, which is the important source as a carbon sequestration in the Arabian Gulf and the Red Sea. And he found that the seagrass has the larger contribution, then while the mangrove had the highest sequestration rate, while the subcap region, the salt marshes will have limited knowledge and we need more studies in the future. Then we have Dr. Barnes gave us an inspiring talk about what and how forms the blue carbon in the polar region. He suggests that the protection priorities should be given to the intact habitat rather than restoration of damaged habitat. Then we have Dr. Bax, who illustrate the cases to show how blue economy can be achieved. And she emphasized that the importance of tools and incentives to support communities in shifting to more sustainable practice. And lastly, we have Dr. Parker, who summarized the environmental performance of the blue foods. In general, he found that the small pelagic fish are very efficient in terms of greenhouse gas emission, while crustacean fishery produce proportionally large emission. Then he also suggested that the great opportunity for the fisheries and aquaculture is to compensate emission from the other food sources. And now here comes the end of the workshop, and we have some time for the final discussion. If everyone who you have any idea to be exchanged or have some issue to be discussed, now you're welcome. You can use the raise hand function or post your questions or idea to be exchanged in the chat box. Right. Okay, so it seems that there are no more questions. So we are at the end of this workshop. And we will circulate the link for the certifications and presentation record afterwards by email. Here, I would like to thank we would like to thank all the speakers for contributing excellent talks and all the participants for joining this workshop, as well as for the KFUPM Kicks organization for organizing this event. And finally, I would like to thank all the CEMS colleagues for hosting this workshop. And thank you all, and I wish you a nice day.